Hello, my name is Zuzana Marcalikova. I am from the Czech Republic. I am PhD student and study on Technical University of Ostrava. I have prepared a paper for this conference with name Study on Shear Behavior of Steel Fibers Reinforced Concrete Small Beams. This paper follows up on the presented paper with name Comparison of Tensile Strength Fiber Reinforced Concrete with different types of fibers, which is also part of this conference. The paper with name Comparison of Tensile Strength Fiber Reinforced Concrete with different types of fiber presents laboratory tests and mechanical properties, especially density, compressive strength, splitting tensile strength, and bending tensile strength. Strength fiber and fiber with double-end bends were used. This paper deals with fiber reinforced concrete with strength fibers, respectively, by shear resistance. The use of fiber reinforced concrete is becoming increasingly popular in civil engineering. A number of projects and professional or research associations are dedicated to research in this area. The wide offer of fiber with regard to material, for example, steel, polypropylene, nylon, shape, for example, strain and fiber with hooked ends, finish, for example, hooked ends, button ends, and cross-section, for example, round rectangulars. It was proved many times that the additions of fiber to concrete improves the mechanical properties compared to plain concrete, especially tensile strength. In case of fiber reinforced concrete, it is necessary to monitor the quality and control mechanical properties very carefully. Fiber reinforced concrete is widely used in the case of industrial floors, parking area, foundation slabs, thin wall structures, and in reinforced concrete beams. Still existing knowledge and recommendation allow the use of fiber reinforced concrete for load-bearing structures to a very limited extent. The aim of authors is to contribute to enrich the knowledge in specific investigate area of fiber reinforced concrete beams within shear reinforcement. Positive feature of fiber reinforced concrete is that when first crack appear, the fibers in the concrete are activated, which are stressed until they are pulled out or broken, which adding the dispersed reinforcement to the concrete. The tensile strength increases, but also the shape of the load displacement diagram changes. A change in the shape of the curve of the load displacement diagram of fiber reinforced concrete in comparison with plain concrete is illustrated in the figure. Magnitude of residual tensile strength is influenced not only by the types of fiber used, but also by the dosage of the fibers. Fiber reinforced concrete structures are still able to carry external loads even after extending the tensile strength. Fracture mechanics or specialized constitutive relations are often used to describe mechanical properties of fiber reinforced concrete. Inverse analysis also is used to determine the mechanical properties. In structure design, modeling on fiber reinforced concrete structure is usually performed using specialized software, which are based on nonlinear analysis and finite element method. The biggest differences in the creation of the numerical model are in the choice of the material model, when the fracture plastic material model was used for the performance numerical modeling. In numerical model of fiber reinforced concrete, it is necessary to take into account the real behavior of concrete, that is, crash of concrete in compression and formatting of crack in tension. Strange steel fibers with fiber dosage of 0, 40, 75 and 110 kg per cubic meter are used for the production of fiber-reinforced concrete basements. A total of 4 test series of samples were made. The basic concrete mixture was made of fine-grained concrete-proof beton baumit. The common material tests include tests to determine compressive stretch, splitting tensile strength and bending tensile strength. In table there are average strength values determined on the basis of test and particular coefficient of variation. The mechanical properties of plain concrete are modulus of elasticity 27.1 gigapascals, cubic compressive strength 55.87 megapascals, cylindrical compressive strength 48.85 megapascals, splitting tensile strength 2.99 megapascals, and bending tensile strength 3.14 megapascals. Based on the 3-point bending test, the load displacement diagrams were evaluated, which are showing the fracture energy for deformation of 8 mm created for the dosage of fiber 75 kg per cubic meter by 60% compared to the dosage of 40 kg per cubic meter. In the case of dosage 110 kg per cubic meter, the structural energy increased by 49% compared to dosage 75 kg per cubic meter. The ratio of fracture energies was very similar for all dosages. Research into basic material properties was followed by experimental testing of beams with a size of 150 on 150 on 700 mm. Beams with 2 bars of reinforced cement at the lower bottom, diameter 10 mm and concrete cover was 20 mm. 2 beams were tested for each fiber dosage. Total of 8 reinforced concrete beams. The test scheme is shown in figure. The test results are given in the form of the functional dependence of the maximal load achieved in the test on the amount of fiber. Regression linear functions shown a good agreement of 0.97. The value maximum load is the load in the press at which the sample was broken. It can be observed that with increasing fiber dosing, the maximum load increases. It can be observed that with increasing amount of fiber, the maximum load increases in which the beam has broken. In the case of lower dosing, that is 40 kg per cubic meter, there was increase of 24% compared to plain concrete. A more significant increase up to 65%, respectively 80%, can be observed in case of fiber dosage of 75 and 110 kg per cubic meter. Now to the very part of numerical modeling. The numerical modeling of reinforced concrete beam simulated a 3-point bending test. The Athena computer system was used for numerical modeling. A 3-dimensional computational model was used for numerical modeling, and edge node isoparametric elements was chosen for the computational model. The fiber reinforced concrete was incorporated into the fractured plastic material model. Nearly all the input parameters were taken from laboratory tests. The value of the specific fracture energy only was approximated when the calculation was repeated iteratively. Two concepts were used to model fiber reinforced concrete. The first concept for fiber dosing 40 kg per cubic meter is based on the use of effective value of tensile strength and fracture energy. The second concept for fiber dosing 75 and 110 kg per cubic meter is based on the actual modeling of the concrete matrix and fiber reinforcement. The input parameters were taken from laboratory tests. The calculations were performed repeatedly. The resulting values of the load-bearing capacity of the elements corresponded to the experiments, where the approximated values used for the calculation are given in table. Resulting values of calculated total load capacity and the mode of failure of the beams corresponded with the experiment. For illustration, a numerical model of reinforced concrete beams with principal stress maximal for fiber dosage 110 kg per cubic meter and maximal load 108 kN is shown in figure. The mesh of finite elements is shown in figure. Conclusions. The paper deals with an experimental study of shear resistance of reinforced concrete beams within shear reinforcement. Concrete small beams, basement reinforced bases, the steel reinforcing bars also with strained and short fibers with dosage 40, 75 and 110 kg per cubic meter were exposed to 3-point bending test. In all cases of fiber dosing, there was a significant increase in load capacity. The study also included the determination of basic mechanical properties which were used in sequential numerical modeling of 3-point bending tests of reinforced concrete beams with longitudinal reinforcement within shear reinforcement. Numerical simulation of spacement made of reinforced concrete beams require knowledge of suitable input parameters which were approximate chosen using two concepts of the reinforced concrete model. Authors were focused on the issue of the appropriate input parameters for nonlinear numerical analysis in future research. Thank you for attention.